For introduction, I will give you an explanation about glass mini. Glass is a solid material that is typically made by melting a mixture of silica, which is sand, soda, which is sodium carbonate, and lime, which is calcium oxide, at a very high temperatures. The process creates a non-crystalline or amorphous structure, meaning that the atoms in glass are not arranged in a regular, which is repeating pattern like they are in crystals. Glass is usually transparent, but it can also be made in various colors and forms. Its properties can be modified depending on the ingredients used in its production.
Glass plays a crucial role in optics and imaging technologies due to its unique ability to transmit, refract, and focus light with high precision. Its use in lenses, prisms, and optical fibers has revolutionized fields such as photography, microscopy, telecommunication, and medical imaging. Glass optical properties such as clarity, light transmission, and the ability to shape light are essential for creating sharp images and enhancing the performance of optical devices. This makes it indispensable in numerous real-world applications, from consumer electronics like camera and smartphone to advanced scientific instruments and healthcare technologies.
The history of glass in optics and imaging is a story of innovation and discovery spanning thousands of years. Early example of glass used for optical purpose around 700 BCE, when ancient Egyptian and Mesopotamian began polishing quartz crystal to create rudimentary lenses, such as the Nimrod lens. These early experiments aimed to mimic the optical properties of water and laid the groundwork for the study of light and optics. By the 13th century, the invention of eyeglasses in Italy marked a turning point. Glassmakers and scientists collaborated to refine optical technology, which culminated in 17th century with the works of pioneers like Johannes Kepler and Isaac Newton. This advancement led to precise lenses for telescope and microscope, revolutionizing both astronomy and biology. Modern innovations such as borosilicate glass introduced by Otto Scott in the 19th century have further advanced imaging technologies. This durable and highly refractive glass has been used in microscope, space telescope, and laboratory equipment, cementing its role in contemporary optics.
I will continue with application of glass. The first one is the SLR camera in photography and cinematography. In photography and cinematography, the SLR camera use high-quality glass lenses that are essential for producing professional-grade photos and films. These lenses offer precise control over light, allowing photographers and filmmakers to capture sharp, clear image and incredible details. Second application is microscope in medical imaging. In medical imaging, microscopes rely on glass lenses to provide the clarity needed to observe cells, tissues, and microorganisms. This allows doctors and researchers to make accurate diagnoses and conduct detailed medical studies, which is crucial for advancing healthcare. The last one is television in consumer electronics. In consumer electronics, television use durable glass screens that not only provide a clear, vibrant display but also offer scratch resistance and durability. This ensures that the TV can withstand everyday use while delivering high-quality viewing experience for users.
Hello everyone, today we'll take a closer look at some practical examples of optics that we encounter in our daily life. First, we have a prism. These are three-dimensional shapes with identical ends called base and flat side known as face. Prisms are essential in optics because they disperse light into its constituent colors, creating beautiful rainbow and aiding in scientific discoveries. Next, let's move on to fiber optic. Fiber optic plays a critical role in modern communication. They are used to provide high-speed internet, provide high-speed telephone and TV service to home and business. Their efficiency and speed make them a cornerstone of digital connectivity. Finally, we have polarizer. This optical filter allows light wave of a specific polarization to pass through while blocking others. Polarizer are widely used in photography to reduce glare and enhance contrast, and in everyday item like sunglasses to cut down on reflective light. Now that we have explored example of optic, let's move on to example of imaging, where light and optical technologies are used to create visual representation. First up is medical imaging. Techniques like MRI and CT scan fall under this category. This method provides three-dimensional representation of the human body, helping doctors diagnose and treat various conditions. Next, we have holography. This fascinating technology captures 3D image using laser light and interference patterns. It is used in fields like security, art, and even futuristic display, giving depth and realism to visual data. Lastly, let's talk about the endoscope. This device uses optical fibers and a camera to visualize the interior of the human body, making minimally invasive procedures like colonoscopies and surgeries possible. Optical advancement. Underwater touchscreen. Let's start with underwater touchscreen, an amazing innovation in optical technology. This screen uses special material that store light and release it when pressed. This makes them perfect for use underwater, allowing divers to navigate or communicate easily. Next, we have advanced optical technology, AOT. This field focuses on using light in groundbreaking ways like creating tiny lasers, sensors, and even virtual reality systems. These technologies are transforming industries like healthcare and communication. Finally, let's talk about barcode scanner. This device uses light sensor to read and process barcode quickly. They are essential in store and warehouse, helping manage inventory and making checkout faster and more accurate.
We move to the next slide, which is benefit and advantages of glass in optics and imaging. Number 1, high transparency. Optical glass allows up to 99% of light transmission with minimal absorption, making it ideal for lenses, microscope and telescope that require clear and precise imaging. Number 2, control over light behavior. Customizable refractive index, enhanced focus and image sharpness, especially in cameras and microscope. Low dispersion minimize splitting of light into colors, ensuring accurate colors reproduction and reducing optical distortions. Number 3, durability and resistance. Resistant to scratch, extreme temperatures, and environmental conditions like humidity or chemical exposure. Long-lasting material with reduced maintenance costs. Number 4, versatility in application. Essential in consumer electronics such as smartphone cameras and AR or VR systems. Key for imaging systems such as medical devices and space telescope. Number 5, miniaturization for advanced technology. Used in integrated photonics, where glass components enable compact design for quantum computing and telecommunications. Lastly, number 6, fiber optic benefits. Glass fiber ensure efficient data transmission over long distance with minimal loss, making them invulnerable for communication networks, medical imaging, and scientific research.
There is many challenges for glass in optic and imaging. The first one is material properties. Glass can be brittle, making it prone to cracking or shattering under mechanical stress. Manufacturing glass, which consists optical properties, can be challenging and costly. The second challenge is coating and surface durability. Coating on glass degrades over time, especially in harsh conditions. Moisture, dust and UV exposure affect clarity and durability. The last challenge is weight. Glass is heavier compared to alternatives like plastic, limiting its use in lightweight designs. The weight disadvantage makes it less ideal for portable optical system.
Next, future trends. First, smart glass and augmented reality AR. Smart glass is revolutionizing wearable technology with transparent, flexible glass, enabling devices like smart glasses to overlay real-time digital information into the user's view. For example, like Google Glass and Microsoft HoloLens showcase how AR can enhance everyday tasks such as navigation, communication, and work. And this technology will continue to evolve, making AR more accessible in daily life. Second, sustainable glass materials. As the demand for eco-friendly solutions rises, glass manufacturers are focusing on creating recyclable and energy-efficient glass. Corning's Gorilla Glass is an example of durable. Future advancement will expand this to products like solar panels, combining high optical performance with sustainability to reduce environmental impact in industries like consumer electronics and medical imaging.
In conclusions, glass is a very versatile and essential material used in everything from windows to smartphones. It has evolved over time to become stronger, more energy efficient, and even smart. Despite challenges like fragility, its benefits make it invaluable in daily life and technology. The future of glass looks promising with innovation like energy-saving windows and advanced smart applications.